So, hello everyone. My project name is Roller Support. It contains three components. The first component is base. Here is the front view, top view, and the side view of the base, and the quantity for the base is 1. The second component is roller, and the quantity for the roller is 1. The third component is shaft, and the quantity for the shaft is 1. So in the assembly, you can see here the base is fixed and the roller is attached between the base with the help of shaft. So we will see this assembly as well as one by one model drawing in CATIA in a practical way. So in the first step, we have drawn the sketch on the front. So I have taken all the dimensions that are shown here into the consideration. So as per these dimensions, I have drawn the model. So after drawing the model, exit the workbench and extrude the sketch that you have drawn. Then the next is I have given the fillets to the component, this base, and the second step would be the second stage that I have drawn for the circle. Then exit the workbench and extrude the component and then mirror the same component by creating one plane on the mid plane. Then next is the pocket. The pocket is for the shaft to be passed through the base, and the next stage would be rib that I have drawn on the one side. Other side I have taken the mirror, and the next would be the holes for the fixing of the base. So here we can draw one by one step for the base. So the next component will be roller. So we will see the steps for the roller. So as you can see here, the roller looks complicated in the drawing, but it is not complicated. It just takes one revolve command to create this roller. So I'll show you. So I have created the sketch for the roller. So as we are going to revolve for the roller, so I have drawn I have taken only this upper portion sketch into the consideration. Then after that, I have exit the workbench and revolve the component by selecting this axis as the revolution axis. And I have created the other things also. So the first will be the pad. So I have created one pad on this surface of the roller and I have mirrored the pad onto the opposite side. Here you can see, and for the shaft I have taken into the consideration of the pocket command, and I have added the extra features such as edge fillet, so which is already indicates into the drawing. So here you can see there is a R2 of radius for the roller. Next component will be shaft, so we'll see the steps for the shaft also. So for the shaft, I have drawn the sketch of diameter 14 and then exit the workbench, extrude the shaft by the length of 70 mm. So as I have taken mirror extended, so I have written here 35 mm, and there is a chamfer of 2 mm and 45 degree. So I have drawn that also. Click on OK. Then we'll see the assembly of the all these three components together. So for the assembly, click on Start, Mechanical Design, and the Assembly Design. So here our assembly interface is shown here. So we'll insert the component one by one. So for that, we'll click on existing component. After that, click on product, insert the component. So I will insert the base first. Click on open. So here you can see the base is open. So Before continuing for the further assembly, so we have to check the degree of freedom for the base. For that, click on part, right click on the part object and then check for the components degrees of freedom. So it says it has 6 degrees of freedom. So we want 0 degrees of freedom. So we'll fix the component. Okay, now we'll, so here you can see the constraint fix is applied to the base. So we'll again check for the degrees of freedom whether our constraint is applied or not. So here you can see there is no degrees of freedom. Then the next component will be roller. So we will add the component, click on product, we will add the roller, click on open and we'll reposition the roller and then click on OK. Again, we will check for the degrees of freedom for the roller. So click on the part, check for the degrees of freedom. So here it is also having 6 degrees of freedom. So we'll give the constraint to the roller. So first constraint would be this roller should be coincident with this base. So we'll use the coincident constraint. We'll click on axis to axis coincident. Click on the roller axis and then click on the base axis. And then we have to update the constraints that we have earlier applied. Click on update. So here you can see the coincident constraint is applied to both roller and the base. And the second constraint would be contact constraint because this surface should be in contact with here this face. So click on contact constraint. Click on the surface to be contacted with the roller. So click on the other surface on the roller. Here you can see the contact constraint is added but we haven't updated yet. So we have to click on update command. So here you can see the contact constraint is applied successfully. Here you can see it is applied successfully. I'll zoom in. Okay, so here you can see surface contact. So this surface of the base is contact with this surface of the roller. So we'll again check for the degrees of freedom whether our constraint applied are properly or not. So click on the part, then click on the components degrees of freedom and here you can see the rotation constraint is there. Because it is roller, so we need one rotational constraint for the roller. The next component will be the shaft. Click on existing component, click on product, then insert a shaft, click on open. So we'll reposition the shaft, then click on OK. So first of all, we'll give the coincident constraint of axis of shaft with the axis of base. So we will use the constraint of coincident with the axis of base. So we will update the constraint that we have applied. So here you can see the shaft is in line with the base axis of the roller and the base. Now we will insert this shaft into the hole of the base and the roller. So for that we will use the offset constraint. Click on the surface of the shaft and then click on the surface of the. So here we want the constraint in the opposite direction. So we'll change the direction. Now we will add the distance of offset of 65 minus 65. Click on OK and then click on update. So here you can see the shaft is inserted into the roller and to the base. Now we will see the exploded view of the assembly. For that you have to click on the exploded view here so as it can explode the entire product. Click on OK and yes. Here you can see how the explosion happens. So here you can see the base, roller and the shaft. So This makes easier for the person to understand how the assembly should be done. So we can do the exploded view. Here you can see that. I have shown it earlier also. Now if you have to go back to the exploded view, back to normal view, you can just click Ctrl Z, or either you can do the update command. But update command won't fix the assembly entirely, so it's better you can do the Ctrl Z command. So if you have to save the exploded view for the further applications, so you can save it. So I will once again create the exploded view, and I will click on enhance scene to save the exploded view. I'll give the naming to it, and we want the full view. So click on full, click on OK. So here you can see the enhance view. Click on the save viewpoint and exit the scene. So here in the applications, you can see the scenes that we have created is shown here, exploded view into the feature tree. If you want the section view of the assembly, then we can do it by clicking on sectioning. So click on sections. So it will open the two windows. I'll adjust the windows here. So here you can see the section view. So if you want section on the front side, here you can see the arrow. You can adjust the arrow as I'm moving the plane. So in the second tab, you can see the section view is also got changed. So I will keep it at the center. And if you want rotational exploded view, you can rotate the plane that we have created. So here you can see into the second tab, as I am rotating the plane, the section view is also changing. So after creating the section view, you can just click on OK and just maximize the view. Here you can see the section that we have created is here. So this is how we can do the assembly of a component. And if you want to check the clash between the components that we have assembled, you will just click on the clash. So we will check the clash for the entire product here. So here there is an option for between all components or between two components. So I am checking the clash between all the components. Then I will click on OK. I'm checking the type of clash is of contact or plus actual clash. Click on OK. So if you want to apply the clash, you can apply it here, and here you can check the status of the clash one by one. So it says relevant. Then the second status is also relevant. The second clash is between the shaft and the surface contact of the roller. The third clash is between the roller and the shaft. The status says relevant. When the status says irrelevant, that means there is a clash and we have to fix that clash. So here all the status are relevant. So we'll click on OK. So which means our assembly is accurate. So this is how we can create the assembly. Thank you.